Aerodynamics describes how things move through the air. Aerodynamics also has an impact on anything that moves through the air, including kites flying and rockets taking off. The four guiding principles of aerodynamics are weight, lift, drag, and thrust. Aerodynamics in F1 cars is one of the uses of aerodynamics. Aerodynamics' main goal is to create downforce, which forces the wheels harder into the ground and increase the tire traction of the F1 cars. One of the aerodynamic devices on F1 cars is the rear spoiler. It helps to delay flow separation, and the greater pressure in front of the spoiler can help to provide downforce to lessen lift on the F1 cars. Due to the decreased rear lift, it increases high-speed stability while occasionally reducing drag.
As for problem statement, we have chosen Formula One car as our example. The rear wings, or so we call the spoilers, do make the car look sophisticated and a daunting machine, but it is not solely meant to impress, especially in the automobile industry. The spoilers plays a very important role in keeping the cars on the ground. Without it, there is every likelihood for the car to hover off, if not take off, and the drivers will lose control of the car. The result will be catastrophic.
Hello, my name is Edwin, Chendai, Anak, Lay, matrix number 73426. Now, as for the first slide, I'm going to explain about governing fluid mechanics principles. External flow. Firstly, drag is the force that a flowing fluid applies to a body in the direction of the flow. Secondly, the drag operates in a direction that is parallel to the flow of free stream fluid. Thirdly, like friction, drag is typically an unfavorable impact. Therefore, we want to keep it to a minimum. Fourth, depending on the Reynolds number, a fluid flow typically consists of laminar, transitional, and turbulent regimes. Now moving on to the second slide. Governing fluid mechanics principles, Navier-Stokes equation. Firstly, principles regulating fluid mechanism can be used to study fluid motion and discuss the physics of several phenomena of importance to science and engineering. The widely used mathematical model to look at changes in such properties during dynamic interaction is the Navier-Stokes equation. Thirdly, the equations are adaptable to the problem's specifics and are represented in terms of the fluid's assumptions along with the laws of conservation of mass, momentum, and energy. Fourth, incompressible fluid simply assumes that the fluid has constant density and is also isothermal, which means the temperature is constant at all times. Whereas Newtonian fluid assumes that viscosity is constant. Now moving on to the last slide. Relationship between Navier-Stokes equation and CFD. Firstly, Navier-Stokes equation can be used to calculate a fluid's velocity, pressure, temperature, and density. Secondly, by taking this measure, the computational complexity of CFD simulations can be reduced. Thirdly, to solve a complex fluid problem, there are only a few stages. Fourth, it is necessary to understand the fluid's properties. And finally, numerical discretization techniques such as the finite element and finite volume methods must be used. That is all from me. Thank you.
Hello everyone, my name is Muhammad Alzam bin Amrun alias Ajis and my matrix number is 75823. So for the effects on flow and system, so the first one is increase downforce. When Formula 1 travels, the airflow velocity is low and the pressure is high on the spoiler's upper surface, whereas the airflow velocity is high and pressure is low on the spoiler's lower surface. As a result, the wings produce downward force or downforce, and increased downforce delivers many benefits, and one of them is improved tire cornering force. The second effect is that the convergence of the air creates vortices, which increase the drag on the vehicle. The drag caused by vortices slows the vehicle's speed, and vortices form as a body moves through the air. The vortex intensity is related to the speed of the object. And what will happen if the spoiler is removed from the vehicle? The F1 may not be safe to ride on without spoilers. When the car travels at high speed, there will not be enough downforce. This will cause the vehicle to lift, and the car will have a higher chance of getting into an accident. That's all from me, thank you.
Hello, my name is Castellow bin Hafiz and my matrix number is 74774. Today I'm going to explain how to overcome the overwhelming air drag that created by F1 car. So as you know, F1 car has the very big spoiler in the back and in front too, but we focus on the back. There's very big spoiler which is that created more downforce but also created air drag, a lot of air drag. So the bigger the spoiler, the slower the car is, but it's easier to move. So we introduce this solution by using a new system which is DRS. DRS in long term is drag reduction system. Specifically in F1 car, which is the angle of the spoiler wing can change from the normal state, which is like this, become straight like this. So function of DRS is when the car goes straight, to reduce the air drag, we must remove by the function of the spoiler. By instead of removing the spoiler of the angle of the spoiler with the wing, we can change manually by near flat degree, so the air easily come through and reduce a lot of air drag. So the car will move very fast in the straight line, but if the car want to corner, the F1 car want to corner, they turn off the DRS system, which is the spoiler will back to normal and the car will move and corner easily because of the downforce created by the F1 car. So that's the simple explanation of DRS that can solve this problem of overwhelming air drag in F1 car, in the spoiler they created by F1 car. So I think that's for me. Thank you.